In this video, we're going to look at how to make an equation from a graph line. And so we've got our coordinate grid here, and just adjust this. I feel like I've got a little bit of fuzz there. Okay, we've got our coordinate grid here, and then we've got the graph line coming down right here. Right? So the first thing when you're going to do is, when you're going to make that equation, is you need to find your key features. So the key features that you're looking for include your change of y over your change of x, also known as your rate of change or your slope. Okay. Everything we've done up to this point is always, the rate of change is always in blue, so I'm going to continue to do that. Change of y over change of x, that's one key feature we're going to look at. And you have plenty of other resources to look back in your classwork, back in some other toolkits. How do you find change of y over change of x, or what is that? And the second piece is your y-intercept. And I'm going to write that as 0, something, because that's the point where it goes through the y-axis. And in everything else, we've labeled that as green, so I'm going to continue to do that here as well. So the easiest part to identify is your y-intercept, or your initial value. So I'm going to find that first on this graph. And as I had said, the y-intercept is the point where the graph line is passing the y-axis. So if this is our y-axis, it's where it's intercepting the y-axis. That's where before there's any minutes, so when minutes is 0, how many feet away are we from this object? And you can find that right there. Okay. And that always happens. So if your graph line starts here, you might need to extend it out, right? Because it might not, the line itself might not be drawn all the way there. That point there is 0. I've gone over 0. And I've gone up to the 50, 0, 50. So I'm going to write that my key feature here for my y-intercept is 0, 50. Second piece that we're looking for when you are finding an equation from a graph is you need to make your rate of change, or find your slope here. Change of y over change of x. So on our graph line, we have to find 2 good points. And that's kind of the hardest part that people have, finding the 2 good points to work with. Means a point like this, where it's going through the 2 grid lines, those blue grid lines of the graph paper. This right here is not a good point because I don't know precisely what number that is. It's 2 point something or 2 and something, but I don't know what that extra part of that number is. This is not a good point because I don't know exactly where between 25 and 30 that number falls. But here's another good point. And here's another good point. All of those are good points. Okay, so I can make a nice big triangle here. I can make a smaller one. At this point, it does not matter. So I'm going to do my change of y over change of x between these 2 values. And I'm going to do this 2 different ways. You only have to do it one. All right, so far, just taking the blue, so we're following along with knowing that we're doing our slope, or our rate of change, finding those 2 points. I can also take those 2 points and sketch a table of x and y. Okay, so as I look at this point here, this point is the coordinate point 2 and 35, 2 and 35, and this point here is 4 and 20, 4 and 20. Okay, to find change of y over change of x on a table, we've done that many times, and what we can do here is figure out how much this is going up by. This is our change in our y, this is our change in our x. Change in your y, I'm going from 35 to 20. That changed by a negative 15. 35 minus 15 gives me 20. This is went from 2 to 4, so 2 plus 2 gives me 4. Okay. So in this case, our change of y is negative 15 over 2. And that simplifies down to negative 7.5 for every 1. That's looking at it on a table. I want to now see that on a graph. Okay, finding that same idea, what we just did there. This is our change in our y, because our change in our y is our vertical change. And our change in our x is our horizontal change. You can see that because this is our y value. If I draw a line down, I'm changing from 35 to 20. It's exactly what we just did here, right? 35 to 20. That gives me a change of 15. But as we had said here, it's not a positive 15. If I'm driving from this point to this point, I had to reduce by 15. I had to go down, going down by 15, because we read graphs from left to right. So that's going down. So that's negative 15 over my change in my x. Now I'm at this corner, I'm making a left-hand turn, like as if I'm driving and trying to get that to that destination point. My change in x went from 2 to 4, so that increased by a 2. That's where that 2 is coming from. Negative 15 over 2 gives us negative 7.5 for every 1. And there's our rate of change, or our slope. The value we're going to be using there in our equation is the negative 7.5, because divide by 1 doesn't change anything. And the value we'll be using here in our y-intercept is the 50. Okay. So when you go to make that equation, it looks like y equals y-intercept plus rate of change. So I'm going to put ROC, rate of change, times x. And this can go either way. The rate of change just has to be multiplied by x. So it's just a formula we're using now at this point. And we're plugging in our values. So now that I've colored it, we can see up here y-intercept says it's 50. So it's y equals 50 plus our rate of change, which is negative 7.5. So I'm going to put, I could put plus negative, or I could put minus 7.5, and then I've got x. Okay, there's my parts. Oops, sorry. There's the 50. There's the negative 7.5. Now this should work for every single point. Like for example, this point right here is the coordinate point 2, 35, right? And our coordinate points are always in x comma y. So the 2 is x, and the y is 35. So if this is a true equation that works, then I can use that coordinate pair to verify that. I can say 50 minus 7.5, and instead of x, my x is actually 2 at that point. And that should equal, instead of y, that should equal exactly 35. And it does. So there's your coordinate point in your equation. Remember, the x and the y's are just placeholders for you to put in values.